Everyone, this is yours Peels with another episode of 3D Printing News Unpeeled, together with 3dprint.com. Today we're going to go talk about the top 3D printing and additive manufacturing news of the day. And we're going to start with the US Navy working with MatterHackers. So this is the news that the Naval Information Warfare Center, NIWC, has entered into a CRADAR cooperative research agreement with MatterHackers. What they're doing is the exciting bit. I mean, we're seeing a lot of navies and naval kind of applications grow up, but this is a kind of new one with a twist because rather than looking at just industrial equipment or really high-end equipment or making their own things, what MatterHackers is going to do for the Navy is to identify open source desktop 3D printer materials and printers that can be used to deal with all the problems and parts that they need to make in the Navy and specifically with the US Marine Corps. So they're looking at low cost expeditionary printing, so stuff that they could do in the field, overseas, or while underway. And what they're looking at is commercial off the shelf solutions. So it's stuff that is available, it's stuff they don't have to hack it, upgrade it, order some super special military version that's 10 times more expensive. No, they want to use the same Prusa that you and I use, and they want MatterHackers to find out these cases for them. Now, I think this is a very cost-effective, very exciting kind of thing that they're doing because this is looking at low-level parts, low-hanging fruit, easy to do stuff. You know, they're looking at $1 to $2 parts that can really make a difference to a ground vehicle, to a soldier somewhere in the field. And this is, I think, where we can see a lot of the attention going to. What's also very encouraging is that one of the focus areas for this is software to identify 3D printed parts, software to share these files, and to kind of like, you know, similar to a Thingiverse, kind of like that kind of functionality. They're also looking at that. And what I found in implementing 3D printing in large organizations is that's so key to have kind of your own internal Thingiverse that's secure, that you can share files, that Sarah in maintenance can show how she really made this case happen and that she really designed this part, what she used to design it, that the part cost $2, you know, including all the G code and the settings, all the stuff you need. But really importantly, that she tells her story and shows the pictures, and that really inspires people to do to kind of define the right applications and to kind of like dial in what good applications are. So I think this is very encouraging. And one other thing is that is encouraging is they're specifically looking for filament, so bound filament that can lead to metal parts. And that is already something we've discussed earlier a couple of days ago with Nanoway, where I'm working with the Dutch Navy, where this kind of bound filament kind of approach, where you can use a low cost system to make a metal part. It won't be suitable for a lot of metal parts, but for the parts it's suitable for, it would be a very low cost, very cost effective solution. So the next piece of news is Leslie Locke and Sasa Zivkovic, who are both professors at Cornell, and they're also co-principals of something called the HANA Design Office, are using Cobod and Peri construction to 3D print a house. Now, so far, so normal. But what these guys are doing is doing a multi-story house, which includes a 12-meter chimney and a two-car garage and 3 bedrooms, 3 bathrooms. So it's a quite considerable 3D printed kind of structure, or complex 3D printed structure that they want to mass customize and make modular. So they want to design it in such a way that it can be a mass customizable modular home. You could go at one point maybe to their website or something like that, and you could customize that home, and that could be produced either on site or somewhere else. And they wouldn't have to design every single house, but they would then just design the master plan for these homes. Which would seem to be a very cost-effective thing to do. What's also novel about this is that they're going to be using wood framing. So wood framing in the United States of America is a very common construction technique, and very old construction technique that uses wood, which is a very sustainable material. And their logic is to use this material to have these familiar, very nice materials around people and the familiar construction methods, and also use 3D printed construction where it's actually needed to kind of reduce it from just trying to print everything. And I think this shows a real maturity in 3D printing construction. from the architects, because they're not just trying to print some space age Jetson looking design. They're not just trying to 3D print something cool. No, they're not trying to print the whole building in 24 hours to get the media's attention. No, they're trying to do something which, makes it very applicable and relevant for people's lives, and makes it also cost effective and environmentally friendly. So this is very mature. It's a maturing of the 3D printing construction industry. So we think we're very encouraged by this. The next thing is also 3D printed concrete. In this sense, this is also a use case that's been around for a bit, and I just haven't known about it. So I thought I'd share it with you just in case you missed it as well. This is the Uithoorn project, which is a Dutch project by Dura Vermeer. Dura Vermeer is a really large Dutch builder of infrastructure. They build like bridges and stations and stuff like this. And they used Saint-Gobain Weber Beamix, which is a materials company, really large materials company that has a 3D printing arm. Their 3D printing arm is different in the sense that they 3D print things in a factory, and then they ship these modular components to the end user, and they really focus on formwork and kind of ready-made 3D printed objects. What I like about this is they used it for slope stairs. So I'll show the next picture. This is a 3D printed slope stair. So slope stairs is any kind of stair that's meant to kind of go down a slope, right? Like, for example, at a train station or an embankment or something like that. This is a very common use case. They look at steel stairs, or they looked at concrete reinforced prefab stairs. What the guys at Dura Vermeer found out is that since there's no reinforcement well, it's actually cheaper than the fully steel stairs. And since there's no reinforcement and there's less concrete used than in the prefab stairs, that actually these 3D printed slope stairs are actually 30% cheaper than the prefab traditionally made ones. And at the same time, they're also more sustainable. So here's a case where it's not la-di-da-da future, very exciting kind of Jetsons kind of stuff again. This is really a really realistic case where they're saying, look, this is cheaper for you, and this is more cost effective for you to do, and we're using less concrete, so it's more affordable and also better for the environment. What they do here is the top bit, let's say where the entrance to the stairs is, and gets shipped together with two separate elements that that comprises the whole stairwell, and that's shipped on one vehicle. And the entire stairway is 9 meters long, and it has a height change from bottom to top of 4 meters, and it weighs a total of 2.5 metric tons. So it's quite a considerable structure. So far, there's over 12 of these in operation across the Netherlands and more internationally. So this is an application I really missed. I don't know how I missed it. I'm being stupid, but I love this very, very much. Also because, and this is kind of like very coincidentally from the before news item, that what Saint-Gobain Beamix, Weber Beamix has on its website is kind of a customization tool. So you can put in your width, your length, all the different kind of things you need for the stairwell, and then it will get designed on the website. Now, I like this for two reasons. One, it makes the design process much easier, right? By the way, this is compliant with all the relevant Dutch building codes, right? So it makes the design easier, and it also, as a local county council or an infrastructure company or somebody who has a building, you can look and very quickly determine what stairs were there. It becomes very real, and it becomes like a very close to you kind of object that you can then order. So you're really taking construction, which is a very difficult business, lots of meetings and phone calls, and you're making it much faster, and you're able to close people much faster on these things and make them very real very quick. So I love this. I also think that if we're looking at 3D printing construction, I really believe in formwork, right? Because the case is there, the business case is there, especially in complex parts and tunnels and things. I'm not so much a believer in 3D printed houses, but so many people believe in it that we'll probably make it real, right? But what I do believe in is things like these stairs and things like bridges, like small bridges, bridges for bicycles, bridges for people walking over. I also believe in things like planters and other kind of prefab kind of things. I think these kind of elements are going to be much cheaper to do with 3D printing construction. I think the real breakthrough applications to me aren't in monuments or in houses, but the one thing to get up to volume are things like, for example, planters and concrete elements and things like elements to use for streets and embankments and stuff like that. And also now these slope stairs, and this is why I'm so excited about this application. The next thing is our top news item. This is quite remarkable, actually. This is Velo 3D has sold seven 3D printers, seven Sapphire 3D printers to Kefton Industries, or a subsidiary of theirs called Kefton Technologies. This is a relatively new 3D printing company, or a relatively new company to the market. It is a manufacturing firm that services space, aviation, defense, oil, and gas, right? Now we're seeing so many people focus on this market because the cost of quality is the same. They all like to use Inconel and all the same types of materials. They have very similar designs, and Velo 3D is really focusing on getting these type of customers. So they have the customers that we know of, like SpaceX, Honeywell, Lam Research, Hermes, Lockheed, these kind of guys, and very prestigious, very wonderful. But there's a new class of customer emerging, right? Um, Unlike these guys, these Kefton Industries, where you're seeing a company that does CNC in-house, they do EDM in-house, they're relatively new to 3D printing, but through 3D printing, they can adopt a much bigger client base. They can introduce their existing clients and cross-sell on these 3D printed goods. What we're also seeing is that, you know, Velo is not focusing on doing business with traditional service bureaus. Instead, it's looking for these manufacturing companies that want to make the leap to 3D printing, right? So, like Knuss Goodwin is another one of their customers where we're seeing that these guys are wanting to serve more customers than just oil and gas, and they're using 3D printing to broaden their base to look at these defense and aviation industries. And I think that's really a match made in heaven in terms of customer base. So I think Velo 3D's laser-like focus on the right customers and the right people, not just anyone who'll talk to you, not just anyone who wants to, who's a lead or ask for information, to really focus on these manufacturing firms rather than service bureaus, and to focus on these manufacturing firms rather than universities and a lot of other people is really paying off for them. And this is a huge coup for them to sell seven systems to a relatively new company. And yeah, really, this is really holding up. And we're really seeing a consolidation. We're really seeing companies like Syntavia, More 3D, really kind of get ahead of everyone else in the quality kind of area, making these high quality parts. But we're also seeing new manufacturing companies transition to AM and try to play in that really high tech, hypersonics, space, satellite, new space arena. So this is very interesting. Now, who's getting left behind here is the traditional 3D printing service bureaus that have a lot of experience with the technology, but don't have this manufacturing kind of this really huge focus on manufacturing. So that's I think a really big trend. So not only great day for Velo, this of course, but the bigger trend here is that we're having new entrants, we're having companies that are really upping the game in quality, and we're and also really large volume companies like GKN and all this. But who's being left behind? The really experienced traditional 3D printing service bureaus. So that's I think a very notable trend. So thank you so much for your attention today. My name is Joris Peels, and this is another episode of 3D Printing Unpeeled.